So now we're going to look at how to solve systems of linear equations by the elimination method. Okay, so the goal with elimination is to get one of the variables to be eliminated. So if we look at this example, this is a great, easy example. If we take these two equations and we add them together, okay, what we're going to have is that this positive 9y and negative 9y are going to be eliminated because 9y minus 9y is just 0, right? They're going to cancel each other out. So now we just add the other things together. 5x plus 12x, they're like terms, so we get 17x. We've got to make sure that our equal signs are lined up, and 10 plus 41 is 51. And now if we divide both sides by 17, remember we can't solve an equation when it has two variables in it. So we take two equations, we get the y's to cancel out. I only have one variable left. Now I can solve this. So here we're going to get x equals 51 divided by 7 is 3. So I have an x value of 3. This one has an x value of 2, so I'm going to cross that one out. We have an x value of 3. This one has an x value of 3, and this one we can cross out. All right. Now we're going to take this x value of 3, and we're just going to substitute it back up into either equation and then solve for y. So I think I'll use this first equation. We have 5x, but instead of x, I want to use 3. So instead of 5 times 3, I'm just going to write down 15. 5 times 3 is 15. And then we're going to add 9y, and it equals 10. Remember, I was just rewriting this equation, but instead of x, I went ahead and used the value of 3, and that gave me 15. Now, if I subtract 15 from both sides, we'll find out that 9y equals negative 5. So when we divide both sides by 9, we find out that the y value is negative 5 over 9, which makes this one the correct answer. And not choice B, we're going to go with C. Okay? All right, so that one was nice because positive 9y and negative 9y already kind of matched. I mean, they matched in a way that enabled them to cancel out. Positive 9, negative 9 equals 0, so those cancel out. So this one's close. 9x and 9x are the same coefficient, but if we add these two equations together, what we're going to get here is actually 18x, and 11y equals a really big number. So that's not what we want to do. Remember, the goal is for something to be eliminated. So if I were to multiply everything in this equation by a negative, what I'll have is negative 9x, and then it will cancel with the positive 9x up here. However, if I look at this a little bit more closely, I realize that it would actually be a little bit easier if I multiply everything. I'm just going to go ahead and erase it. If I multiply everything in the first equation by a negative instead. It'll still give me negative 9x, which will cancel the positive 9x, but it'll give me negative 4y instead of negative 7y, and negative 125 instead of 158. So it's going to make this a little bit easier to solve. So I'm going to rewrite this. Actually, I'm going to just keep this second equation right here. Keeping that right there. And I'm going to rewrite this one, but I'm going to multiply everything by a negative. So I'm going to get negative 9x and negative 4y, and they're equal to negative 125. And now when I add these two together, 9x minus 9x will cancel out, or 9x, a positive 9x and a negative 9x cancel each other out. 7y minus 4y is 3y. And 158 minus 125 is 33. I know that wasn't the neatest. Ooh, let's fix this up a little bit. That was minus 125. Okay, I just set this up. I multiplied the top one by negative because that allowed me to just go ahead and subtract. I didn't have to worry about any, getting any negatives down here. Now when I divide both sides by 3, we get y equals 11. Okay, so we have a y value of 11 here. This one, they've got 11 as the x value. That's not what we want. This one is definitely not 11, and neither is that one. So you could probably go ahead and pick A, although it's definitely not a bad idea to go back in and just double check. So I'm going to take one of these equations. Let's try the one with the slightly smaller numbers. I'm going to use the original version of it. So 9x plus 4y. So 4 times y, which is 11, gives me plus 44. It equals 125. I'll subtract 44. So 9x equals 81. Okay, that works out nice. Dividing both by 9, we know that x equals 9. So the x value is 9. Yep, totally checks with what we have. Definitely picking A. Picking A. All right, let's take a look at another one. This one, they almost matched. They actually did match, and we wanted them to cancel out, so we had to multiply everything by a negative in order to get them to cancel each other. Now with this one, it's a little bit more difficult because we have, let's see, 7x and 19x. They're not going to cancel each other. 15y and 5y, they're not going to cancel each other either. So we call this, remember, we call this one elimination multiple. 15 is a multiple of 5. So they're close, they're compatible numbers, but I'm going to have to change this 5 and somehow make it negative 15 so that it will cancel out this positive 15. That's my goal here. So if we take this second equation and we multiply everything by not 3, but negative 3, okay, negative 3 times positive 5 will give me negative 15, which will cancel out the positive 15. Okay, so I'm going to rewrite the first equation. 7x plus 15y equals negative 105. And I'm going to multiply everything down here by negative 3. So negative, let's see, 57x. That's a nice number. And then negative 15y. Remember that was our goal there. And now negative 3 times 65 will be negative 180, 195. Okay. I know they're not the prettiest numbers in the world, but they will work. All right. Those are going to cancel each other out. 7 minus 57 is negative 50x. And negative 105 and negative 195 is negative 300. Yep. Oh, well, this isn't so bad. If I divide them both by negative 50, now we know that x equals negative divided by negative is positive. Let's see, divide them both by 10. That's going to give me 6. So I'm looking for an x value of 6. That's got negative 6. This one has the 6 as the y value. Here's my x value of 6, and that one, again, is a y value. So I could choose C. Now remember, if you want to be sure, take that 6, plug it back in for x, solve for y, and you will get negative 9 4/5 as long as you work carefully. All right, the last one Remember, on the other ones, we either had things that were already in a, all set up to cancel each other out, or we had to multiply one of these by a negative. Now, when we look at these 5x and 4x, there's no multiple there. And 7 and negative 5, we don't have one that's a multiple of the other one. So what we're actually going to have to do here is multiply both of these equations by something in order to get these to match up and cancel out. So we have two options. I mean, you have a couple of options, but one option is to take 5x and 4x and make them both equal 20. One of them needs to be 20 and one needs to be negative 20. It doesn't really matter which one. Or we could take 7, positive 7, and negative 5 and turn them into positive 35 and negative 35. I think that's the option I'm going to go with because we've already got one positive and one negative. I won't really have to worry about the signs. I just have to worry about changing the numbers. So I'm going to multiply everything in this equation by 5. That'll create 35y. And then I'm going to come down to this equation, and I'm going to multiply everything in here by 7. And that'll give me negative 35y. All right. So 5 times 5x, we get, oops, use the same colors here. All right, 5 times 5x is 25x. 5 times 7y, we get 35y. And then anything times 0 is 0. Now with our second equation, we're going to have 28x and negative 35y. And it equals, oh gosh, a really big number. 7 times negative 53. That'll be negative 371. We better check that. 53 times 7 is 371. Okay. All right, now, remember, we're trying to get them to cancel out. That was our goal. Now I'm going to add these two equations together. Remember, if you add something that's true to something that's true, you get something that is still true. So those are going to cancel each other out. 25x plus 28x is 53x, and it equals negative 371. So when I divide both sides by 53, I know I'm going to get a negative, and 371 divided by 53 is 7. Okay, so I have an x value of negative 7. This is a y value of negative 7. We have a y value of negative 7. I have an x value of 7 and an x value of negative 7. So we can choose D. And we can always plug negative 7 back in and solve for y, and you'll get an answer of 5. That'll help you to double check and make sure that you've done that correctly. All right, that was our last example. So I hope that those helped you with the elimination method.